Hi everyone, my name is Adria Brooks and I'm a Senior Technical Advisor with the Grid Deployment Office at the Department of Energy. We're here today to talk about Transmission Planning 101. So the power grid is the highway system for electricity that moves power from where it's made to where it's needed. Without the power grid, we just can't move electricity across the country. So the nation's power grid, it has a really important role in keeping the lights on, heating and cooling homes, charging our phones, importantly, electric vehicles, running manufacturing facilities, just basically keeping all of our essential services going in the US. So the power system, it's made up of many components. We have the power plants, which generate electricity, the grid, which actually moves that electricity, and then load centers. So this could be urban cities or rural communities. The transmission system is really akin to the US interstate system, if you want to think of that analogy. So it's meant to move large amount of electricity generated at power plants across hundreds of miles to where we use it. You've likely seen transmission towers. These are the large multi-story towers, so 10 stories tall, with long cables on your drives between cities or just outside of cities. Now, the distribution system is a different portion of the power grid. That's more akin to the vast network of local roads that distributes electricity from the transmission system, so interstate system, lots of power, into our homes and businesses where we use significantly less power than what is transmitted on the transmission system. And the distribution system, these are shorter towers, smaller cables. I bet if you look outside your window right now, you'd probably see them. This is the system, the power grid that actually brings electricity into our homes, into our businesses. So that's the power lines themselves. Now those are connected to what we call substations, and the substations go between the transmission system, the interstate system, and the distribution system, the local road network that we use to connect to use electricity in our homes. Substations, I'm sure you've seen these look like enlarged fenced-off parking lots. There's lots of metal containers. I've heard these once described as metal jellyfish, which I really liked a lot. So substations, they exist on either end of the transmission system, again, to help change the voltage from these really high power that we need to transmit electricity on the transmission system down to the lower voltages, the lower power that we actually use in our homes, that we use on the distribution system. So the electric grid is arguably the most complex machine in the country. So the planning and building of that system also reflects that complexity. Different regions of the country manage their parts of the grid differently. So in some regions of the country, local utilities, like those that we pay our utility bills to, our electric bills to, they plan and manage their own portion of the power grid. In other regions of the country, those same utilities have come together to form these larger multi-state planning coordinators, these grid coordinators that do all the system planning and operations. Regardless of which style of management in a region, all those utilities are responsible to state and federal regulation of the power grid. So transmission planning can happen in this bottom-up or top-down way. In the bottom-up way, those utilities that manage the power system, they create transmission plans for their service territory. So they know their system really well. They know what new transmission lines or maybe upgrades to existing system are going to be needed in the near term. Now, those central regional coordinators, they also do some top-down planning. So in that case, these regional coordinators are going to look at a whole region, so multiple states, multiple utilities within those regions. And they're going to try to understand, okay, what are maybe some larger transmission lines that would help meet needs across all these different disparate utilities. They would take in those bottom-up plans from their local utilities, and they would also do this top-down planning to help create a more robust regional network. Now, once those plans are approved by the utilities or by the regional coordinator in terms of electrical reliability, any new transmission lines that are proposed would have to be sited and permitted. That's where the regulation comes in, or where those regulatory bodies, whether state or federal, come into play. That process of both siting and permitting, that can take many years, sometimes as much as a decade. And the exact map or route of the transmission lines can go through many iterations. So both the regulators, but then also landowners who are going to be impacted by lines, get to have a say in where the transmission lines go. That's one reason why the siting and permitting process can take so long, is we want to make sure that we're talking to all those different communities in making these plans. Ultimately, any customer paying electricity bills, we call them ratepayers in industry, they're paying for those newer upgraded transmission lines. Now, those costs get spread out over time and across the many different regions that are being serviced by the transmission lines. Again, transmission lines tend to be long, multiple utilities, multiple states, so those costs are spread out. Now, the regulatory bodies, usually at the state level, they're in charge of making sure that ratepayers, that we don't have to pay too much of a cost increase at any one time. That said, the Grid Deployment Office where I work does have several financing tools to help lower the cost of these transmission investments in certain areas. And it's also really important to highlight that paying for grid upgrades does reap benefits in the long term. So by expanding the transmission system and bringing more clean energy to the power grid, consumers are going to have access to clean and reliable and affordable electricity for years to come. If you're interested in more information on this topic, you can go to the Department of Energy's Grid Deployment Office website, where we have a number of resources available to learn more.